very good morning, good afternoon, good evening to all the candidates, participants and my dear friends. Welcome to this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, the three broad topics as we are covering in this course of 60 lectures of 30 minutes, 30 hours in total. The first topic is forecasting, second one is basically regression, third one is time series. And we are in the second topic, which is regression models. Even though it is written as multiple linear regression, but is actually regression, I will consider few more other models also. So, this is week 6 and lecture number 29. That means, with the 30th lecture which will come up the next, we will wrap up 6 lectures out of this 12 lecture series. I would not say lectures, it is basically 6 weeks out of the 12 weeks lecture series. That means, we will complete 50% of that. So, what is the coverage for this course? In the last 2 lectures, which was basically 27th and 28th, we have covered 2 different examples of simple linear regression in details, discussed about what was the data point, discussed how the calculation would be done for each the problem separately, discussed what was the formula, calculated each values step by step and utilize all the values to find out beta naught hat and beta 1 hat, because there was the intercept as well as only one regression coefficient, considering there was only one independent variable. Now, in this problem again we will consider a few examples of simple linear regression, very simple one. And then even though if you see I write the ideas of the coverage, but as it goes, as the discussion goes, and depending on what I think is important to be discussed, and considering all of you are at the other side of the camera, and communication, if in class, it is always both ways. So, it is basically the flow is much more interactive. Here, as the interaction is only one way. So, hence as I speak, many ideas, many problems, many thought process comes into my mind. So, I keep mentioning them. So, in that process, whatever the coverage is planned, maybe I am not able to cover in that in the same lecture, but be rest assured that is covered consecutively. And when you see the PPT slides along with the videos, so the coverage which was planned in the videos, if it is not possible, that is rectified in the PPT slides. And as I said, those coverage of a particular lecture, if it is not covered, then it is definitely taken up in the subsequent lecture series. So, again I am giving the formula. You may be thinking why the formula is being stated time and again, because rather than moving up and down, if we have the formulas at one go, it is easy for all of us, both the participants as well as for the instructor, to refer to the particular slides and proceed accordingly. So, I have the regression models. For n data points, I need to basically minimize the sum of the square of the errors, partially differentiate with beta naught and beta 1, put it to 0, and then solve the equations. 2 equations, 2 unknowns. When I solve these 2 equations, 2 unknowns, I get the values of beta naught hat and beta 1 hat, and based on that we solve. So, now suppose these problems are not directly related to the data, but if you read it, you will understand. Suppose there are 2 regression lines and it is a little bit off the track problem, and the regression lines are given by these 2 equations. So, it is being assumed. Whether the assumption is right or wrong, we will come to that. That is basically the problem. The first equation which is given, which I will mark in red, is x minus 3y plus 6 is equal to 0. All the terms have been brought on to the left hand side and the right hand side is 0. And the second equation, I will use the green one, is given as y minus 4x plus 12 is equal to 0. So, both look absolutely perfect. So, they can be regression problems, and regression means in the sense that either you can regress utilizing the value of y and find out x, or utilizing the value of x you can find out y, which means that in the first problem when I am trying to basically find out the equation of y is the dependent variable and x is the independent variable. In the other case, there x would be the dependent variable and y would be the independent variable. Remember, so in one case I am utilizing the information of x to find out y, and another case I am trying to utilize the information of y to find out the values of x. So, the dependence independent structures for x and y are interchanged. That can be possible because you are utilizing the symbols accordingly. Now, the first question is which one, sorry, this should be one, which one of this regression of x on is the regression of x on y, and which one is regression of x on y on x. So, one is basically regression of y on x, and the other one is basically the regression of x on y. Based on that, you need to find out the second point is that you need to find out the average of x bar, then you need to find out the average of y which is y bar, average of x is x bar. Then you need to find out r. R is basically, if you remember in the last slide of the last session, we were discussing about correlation coefficient. So, the rho symbol was used, and correlation coefficient is always between -1 and +1, both inclusive. So, if it is -1, it means maximum negative correlation, and if +1 means maximum positive correlation, if 0 it means there is no correlation. So, the corresponding value, the symbol which is used for the case of sample, or in the case when you are trying to solve the problem from the simple linear regression or multiple linear regression, the value is, or the symbol is given by R, where I put a green tick mark. Given that, find out Sx. What is Sx? I will come to that within few minutes. I will mark it with violet, and also find out Sy, which I will mark in dark blue. So, these two concepts of Sy and the concept of Sx, S suffix x and S suffix y would be discussed. So, let us go step by step. First, find out which is the regression model of y on x and which one is the regression model of x on y, and then the other two x bar and y bar are easy to find. Now, the first problem, first suppose the regression line of x on y, first one is given as the regression line of x on y, and equation 2 is the regression of y on x. So, we can write these equations as this, and I will go step by step. So, consider the regression models as expressed, we assume as this, which I first one I am marking with violet, and the second one I am marking with dark red. Now, if you find out from this the rate of change or the regression coefficient as y changes, the value of x changes at the rate of 3, which is here given here. So, here you can find out very simply that beta 1 value is 3, while beta naught value is -6. If you note down here, I am not marking, I do not want to make it too cluttered. So, this is -6, which is beta naught value. Now, when I use the second equation, so the beta 1 value, when you are basically utilizing x to regress and find out y, that value comes out to be 4 as given here, and the corresponding intercept is -12, which I am also not marking, just pointing the highlighter there. Now, we know, I am just stating without the proof, if I multiply both the coefficient, that means x on y regressed and y on x regressed. So, if I basically multiply beta xy into beta yx, so x and y, yx basically means what you are utilizing to regress on the other. So, that nomenclature is very simple. If that is true, if I multiply them, the value would always be equal to this, which I am highlighting in green, and this I am stating without the proof. This will be r square, and if you remember r square, I mentioned few minutes back, and I also mentioned the corresponding population concept, which was the rho. So, if it is r square, so obviously we know this would be plus 1, sorry. So, this will be plus 1. So, r or rho is always between minus 1 and plus 1, as I have already mentioned and shown in the diagram. So, if that is the case, then so with these equations, if the value comes out to be 4 into 3, which is 12, which because the square root of 12 basically would not be between minus 1 and plus 1. So, with these two values, it is impossible. Hence, the first equation which I have consumed, which is the violet one, where y values were being utilized to find out x, that means y was the independent variable, x was the dependent variable, and the equation was given by x is equal to 3y minus 6. That is wrong, which means that equation would basically be in that one part, the x would be the independent variable and y would be the dependent variable. Similarly, for the second equation, which is shown in red, actually it is given as y is equal to 4x minus 12, which is wrong. In that case, the equation would be that you are utilizing the values of y, which is the independent variable, and try to basically find out the values of x, which is the dependent variable. So, this is not a direct problem, but a very intuitive problem, given the fact that when you multiply both the regression coefficient, it should be equal to r square, and the r square values as per the concept and idea is always between minus 1 and plus 1, which is being not met here. So, the initial assumption is wrong. Now, to solve it, so if you want to basically solve it, the actual values would be, so to solve 1 and 2, and by the way, and this is interesting, if I plot, I will use the axis, I am not mentioning the axis, these two axes. So, if I basically plot the first equation and the second equation, I am just doing it randomly. I will use the violet color for the first one, and if I use the red color for the second one, where they intersect, that point is the common point, and I use the black color here, where they intersect, that is the common point, which is given by x bar and y bar, because that particular point, which is the average value of x and the average value of y, will solve both the equations. Now, if you want to solve it, you basically solve both the equations, and the common point would basically be x bar and y bar, which comes out to be, I will use green color here, that comes out to be x bar, which is 42 by 11, and the other one comes out to be y bar, for which I will use the light blue color, that comes out to be 36 by 11. Now, the idea is that if you remember, when we are solving the problems and I was showing some diagrams which I mentioned were taken from Green, the econometric book, and in that diagram that it was shown that was what was the x bar value, what was the y bar value, and I did mention that you can utilize those values to find out the common point for the regression line. So, this is the same concept which I am using. Now, here why I have not marked the x and y axis, because the reason being, where you plot the independent variable, where you plot the independent variable would depend on the problem which you are solving. So, utilizing the diagrammic concept, the common point when you solve it, that will give you the x bar and y bar. So, here it says that solve these equations 1 and 2 and you get the answer accordingly. But remember one thing, when you are solving the equations on 1, 2, initially 1 and 2 basically were taken as being given as what was the regression of x on y and what was the regression of y on x, and we proved that that initial assumption was wrong. So, that was the first part. Here the second part we use to solve the common point, which is average value of x and average values of y. Now, from the two equations, because if you remember the main assumption is wrong, so the other one would be the equations which are using. So, here you have y is equal to 1/3 x plus 2, and the other equation is x is equal to, I will use a different color, x is equal to 1/4 y plus 3. So, if I plot it, or if I basically, before plotting, if I pay attention here, so here the rate of change of y with 1 unit change of x is given by 1/3, and the value of 2 is basically the intercept. So, this basically 1/3 would be equal to, say for example, beta 1, where beta 1 is basically the equation being used of this y is equal to beta 1 x plus beta naught, and beta naught is basically 2. So, I have used the green color to denote this equation. If I use the corresponding dark red color, in that case x is equal to beta 1. So, remember this beta 1 symbols are same, but the coloring concept would basically mean that in one case you have basically beta suffix y of x is equal to 1/3, and other case of beta of x or y is equal to basically 1/4. So, you have y plus here I will utilize beta naught again, even though beta naught in both the equations are different. So, in that case the beta naught value comes out to be 3 intercept. So, this value is 3, and this 1/4 value is basically the concept of beta 1 here. So, if I consider, the actual value would be beta of y x is equal to 1/3, and if I use the value, there is a reason why I am using different color, I will come to that again, and if I utilize this one, it is beta x of y is equal to 1/4. Now, what does that mean? The corresponding values of x and y actually means that, and y and x basically means that I am utilizing the informations of x to find out y, and in another case I am utilizing the information of y to basically find out x, which means in the case when I am utilizing the information for x to find out y, in that case x is the independent variable, y is the dependent variable. When I am utilizing the information of y to find out x, it means y is the independent variable, x is the dependent variable. And based on that, we already know that the multiplication of beta xy into beta yx, which is equal to 1/3 into 1/3, will be equal to r square, and finding out the square root of r square, we get r value, which is 1 by 1 in the numerator divided by 2 into square root of 3. For this is an interesting problem, as I mentioned. So, given that two equations, I need to find out which is the actual regression of utilizing the x on y, or which is the actual regression of utilizing the values of y on x, and based on that I proceed. So, hence we know, okay, here we are aware, these are the formulas which I am just writing for the. So, if I am aware the values of beta yx is equal to given by r x y. So, the connotation is that, what, remember, you are regressing x on y and y on x should be clear. So, that is the sum of the squares of sy and sx. Based on that, sx is given, and the formulas being as it is given. So, I basically put it beta yx is equal to 1/3 is equal to 1 by 2 square root of 3, which I have already found out, and finding out, I find out sy as 2 by 3. Similarly, I can find out sx also, given in this formula is if sy is given and s suffix x is not known. Now, again the formula, why? Because as you remember, I am utilizing the set of formulas to solve the different type of problems. Utilizing the simple linear regression model, yi is equal to beta naught plus beta 1 x I plus epsilon I is equal to 1 to n based on the sum of the squares. You differentiate with respect to beta naught and beta 1, which are unknown, because there are two unknown parameters. You get two equations, each put to 0, solve them, and when you solve them, the answers which comes out corresponding to beta naught hat is given by, maybe repetition plus, please bear with me, comes out to be y bar minus beta 1 hat into x bar, and similarly I can find out by solving that equation to get the value of beta 1 hat. Now, as we were discussing about correlation coefficient, if you remember, we have discussed about positive correlation, negative correlation and zero correlation. So, based on that idea, we will consider another simple example, which is example number 29. Consider 100 pairs of observations and their values of x and y start from 101, that is 100 is for the value for x and 1 is for y, and it continues till 100, which is last value of x is 1 and 100 is the value of y. So, based on that, we need to find out the correlation coefficient between x and y, that is question number 1. And question number 2 is that what is the simple linear regression model which we have in order to depict that set of points. Now, if you plot it, simply it gives you the fact that the simple linear regression which we are considering is given by yi is equal to minus xi plus 101. Why minus? Because for increase of y, basically, or vice versa, you can talk about that as x increases y decreases or vice versa. That is point number 1, and the intercept is given by plus 101. So, if I plot it, the actual regression model comes out to be, I will just highlight it on the graph also, which is shown, is given by this, which is of the form y is equal to beta naught plus into x plus 101, which is basically, sorry, 1 minute, this is beta 1, my apologies, and this 101 is basically beta naught. So, this regression line would basically be the blue one which is shown, I will highlight it again, this one, and the regression line is given, and from this you can find out that as beta 1 is minus 1, it means for 1 unit increase in x, y will decrease by 1 unit, corresponding to the fact because there is inverse relationship. Now, this problem, even though very simple, illustrates 2 points. Number 1, to draw the simple linear regression, that is the relationship between x and y, and number 2, to get the idea of the correlation coefficient concept which we had discussed in the last slide, and also bring to the forefront that the regression coefficients which we get, that is the relationship between x and y in the simple linear regression model, gives a very good idea what is the correlation existing between the independent variable and the random variable. Now, I will start the ideas of multiple linear regression, and it will take time for discussion. Ideas you have already got in simple linear model, but the ideas which I go through are just for information. When you are solving the problem, I will use just few formulas, nothing else. So, now when we go to multiple linear regression, it is of this form. And if you remember, in this model, all the problems would be written with a suffix. So, you have basically the equation on the multiple linear regression as y suffix n into 1, that means n number of observations for y is equal to x into k plus 1. Now, what is n? Sorry, x is n into k plus 1. What is n? N is the number of reading. What is k? K plus 1 is the number of the parameters which you want to find out. Why it is k plus 1? Because actually x has x1 to xk, which is fine, but considering there is a intercept also, which would be considered as the extra set of information will be needed. So, once I write it in the matrix form, it will be clear to you. And obviously, beta is of the size k plus 1 into 1, and remember k plus 1 is the number of such rows you have, 1 is basically the number of column, which is 1. And this concept of x, obviously you can understand as it is n into k plus 1. So, there are n number of rows and k plus 1 number of columns, and finally, the error term has a size of n into 1, which is basically a column vector of size n. Now, if you multiply, there should be compatibility. So, on the left hand side, y is equal to n cross 1. On the right hand side, the first term is n into k plus 1, that multiplied by k plus 1 into 1, which becomes n into 1, correct, and then the error term is also n into 1. So, obviously, on the left hand side is n into 1, on the right hand side is also n into 1 plus n into 1 column vectors. So, here xij implies the ith reading for the jth random variable. I is equal to 1 to n and j is equal to basically 1 to k, and that extra kth plus 1 is basically the for the intercept. So, if I write it equation format, y into y suffix n plus 1 is basically a column, if you remember. The first element is y1, second element is y2 and goes to the last element which is yn. If I have a look at, say for example, the matrix X, so obviously it would have the first column would be corresponding to the corresponding fact which will come out in the beta naught values, and the corresponding each row what you have is x11 till x1k, which is basically the reading. X11 means the reading of the first one random variable, the first reading, and x1k means the first reading for the kth random variable. Similarly, if I have the second row, it is x21 into x2k. X21 means the second reading of the first random variable, and x2k means the second reading of the kth random variable. Similarly, if I go to the last row, it is xn1 into till it goes to xnk, where xn1 means the first reading nth value and xnk means the nth value reading for the kth random variable. So, hence the size is n into k plus 1. Similarly, if I write on beta, which I mentioned is of size k plus 1 into 1. Now, that is what was important, which I did mention. If you see, the first value is beta naught, which is the intercept, and the corresponding other values, which I will use the blue color as are beta 1 to beta k, are the corresponding regression coefficient for each and every x1 to xk. And similarly, the error term is of size n into 1, and the errors are given by epsilon 1 to epsilon 2. The actual sets of equations are, if I basically multiply the matrix, you would basically have the first equation is the first row which you have when you multiply. So, you have basically y, which is this is the y1, which is n cross 1, that you are getting from x, which is size already given as here, multiplied by beta plus epsilon, again a column vector. So, when I multiply, this value of y1 first cell is here, and similarly I will be multiplying row column wise as the matrix multiplication is. The first element is y1 is equal to beta naught, which is the intercept, plus beta 1 into x11, it goes to beta k x1k plus error term which is coming out here. So, the error term is here in this place, and the value of y is in this place, and the values from beta naught plus beta 1 x1 till beta k x1k are utilized multiplying the matrix of y x and the vector for beta. Let me use a different color. This is beta. So, I multiply them, then I get the values, and the compatibility is there. Similarly, similarly the second value is x 2 beta naught plus beta 1 x 2 1 till beta k x 2 k plus epsilon 2, which is error 2. Similarly, if I come to the last row, it is y n, the last reading is beta naught plus beta 1 x 1 in beta 1 into x n into 1 comma 1, and the last term is beta k into x n k plus epsilon. So, our main idea is, as you can recollect, is basically to take this error, square them and minimize. That is what we have already done in simple linear regression. We will just give the formulas for the multiple linear regression. With this, I will close this class and continue a little bit more discussion and then solve the problems for the multiple linear regression. Have a nice day and thank you very much.